So guys, welcome to today's class. This is logistic regression. We've entered classification. I told you machine learning is split into regression and classification. The whole AI thing is split into machine learning and deep learning. So for machine learning is regression and classification. So we've entered into classification. Yeah. So let me explain what classification is all about. Sneak peek. Yeah. So yeah, classification is, some are binary, some are multi-class. So when we say binary, it is going to predict either 1 or 0, either true or false. So any data you give it is going to give you true or false, on or off, 1 or 0, and like that and like that. So you can see this from this little graph here. This is obese and this is not obese. So we are going to, this is this weight you are seeing actually is the x variable, is the feature, and this is the target. Whether, so you are going to put your weight in as the feature, as the x variable, and it's going to predict whether this kind of weight will either be obese or not obese. It can fall in the middle actually, like what we have here, whether it's obese or not obese. So it can give you either 1 or 0. It can give you either 1 or 0, on or off. Only few times we have multi-class. We have multi-class targets. So it can give you, like in terms of color, you can say okay, green, yellow, and blue. Green, yellow, and blue. So depending on the data you put in, and that's how it's going to give you the prediction. Let's go to the code. Let's go to the model. So this is the model. Data preparation. Collect the data, pre-process it, collect the data, load it. First of all, we start with the libraries, and these are the libraries we are going to need. All these libraries, take note of them. And just I'll get to explain all of them. All these libraries, we are going to need these libraries. Get the data from your data set, pre-process them, split the data, normalize or scale. Actually, this optional. Okay. Define the model. Then yes, evaluate the model. So in regression, we had something like R squared that was used to evaluate the model's performance. But this one, in classification, we have different metrics. These metrics are used as accuracy, precision, recall, F1 score, and this F1 score seems to be the most important because it's an aggregation of all this, especially this recall and precision. It's an aggregation of this recall and precision. Yeah, so it seems to be the most important. Then model refining. In case the model is imbalanced, and I'll explain all those things. The data set is imbalanced. Yeah, so this is the code. We have the code here. Okay, let's get to the code now. So this is the loading of the data. Bank customer churn. So we are going to predict whether a customer will churn or not. Let us get to the data set. Let's check the data set. This is a large data. Very large. Far from what this is, a few thousands of rows, a few hundreds. So we are going to predict whether a customer will churn or not. Churn means for somebody leaving the service, leaving the company. A customer leaving, not subscribing again, like your cable TV. A customer not like deleting his account, yes, due to one reason. So we are going to track their behavior and predict whether that customer will churn or not. So churn represents 1. Churn represents 1, and the possibility of the customer not churning represents 0. Or you can do it vice versa, depending on what you want. So these are This is customer ID, credit score, country. These are the columns we are using, which are called features, tenure, balance, product number. We are using to predict only this guy, John. So look at the country, Spain, France, and all that. So let's go there. First of all, let me give credit to Cargo. If you don't know Cargo, you can download your data sets from there. I got this data set from Cargo, Bank Chunk Cargo data set. So you can see a lot of data sets here, where you just download your data set. You can come here to download it. You can come here to download so many data sets, and we have a repository too for, just click download here, you downloaded it. So this is very nice. Any data set you want, so many data sets, you are going to see it here on Cargo. So this is a data set I got from Cargo, and here, this is a machine learning repository, UCI machine learning. So any data set you want for machine learning, you can see iris, driving, heart disease, rice, adult, breast cancer, wine quality, and there are so many data sets. You can see how many of 10 of you can see. So there are so many pages here, so you don't struggle with data sets. Yeah, this is YouTube. I got that picture from YouTube. Yeah, that picture I showed you earlier. So let us go there. Let us go to our code. So yeah, this is the loading of the data, pre-processing, dropping any missing column with missing value, and duplicates. We are separating the features. You should be used to this algorithm by now. We separate the features X and Y. And now this class is quite lengthy. These categories you are seeing here, country, gender, and active member, it is because the data values in those columns appear repeatedly. Like country, we have only 3 countries here: France, Spain, and Germany. Is it Germany? France, Spain, and Germany. Yes, we have 3 countries here: France, Spain, and Germany. And we have 2 gender. So you can see that it is just very few. The data values are repeated. Active member is just yes or no. So this data value is repeated. That's why it's called a category. And we need to one-not encode every category. So you can see what's going on here. One-not encode every category. This is how logistic regression works. If I say I should explain the code in total in details, we are going to spend hours. So we one-hot encode them. That's the block. You can see how I just arranged everything. So follow this algorithm very closely. This is the splitting of the data. That's churn. We are dropping churn for the X data. That means it's picking this whole data. We will just drop churn, and then the Y is churn. Then now we are going to use 0.2. That's 20% of the data to test. We scale it. You should be used to this algorithm by now. We define the model. We train it. This fitting is called training. We predict. Yeah. And now we calculate the metrics. Print the metric. Make sure you get this code. This is the new data input now. This is the new data input. So we are going to predict whether a customer will churn or not from each of these rows. This is, sorry, let me make this guy more flexible. You can see from here, include all the columns there except the churn column in the new data frame.